Um, okay, so in this video, I am going to try to explain some concepts that relates to constructing data centers on the planet Moon. And there's also the reason why it's very important to construct data centers on another planet, because data centers on Earth presents so many problems, such as thousands of gallons being used to cool down these data centers, and that takes away tens of thousands of gallons of water from humans. All of this electricity being used to power the data centers, and it takes away electricity uses for humans, makes the price of electricity more expensive, or it also means that in the future power companies are going to make the decision of not allocating electricity for average citizens, but allocating electricity to power the data centers. And there has been videos on YouTube that I have seen in which, like about a year ago, I think in Hawaii, there was a power company that decided that in the next several months, the power company is going to make the decision to not supply average citizens with electricity. So they're not going to do that, but instead the power company is going to supply data centers with all of this electricity. And that's not really fair for the average citizens, because now the average citizens are either going to have to go without electricity, or they're going to have to find a different power company, which it's difficult to do. And even today I saw a video talking about the same thing, in which this video, I'm not sure when it was published, but it was published sometime in June of 2026, in which the power company is not going to supply average citizens with electricity, but the power company is now going to supply the data center with electricity. So data centers on Earth, even though browsing the web uses data, and data centers need to do, and it goes to data centers, and watching YouTube videos uses data and it goes to data centers, and so that's why data centers is relevant. It's just that when people are using like AI chatbots like ChatGPT to make a bunch of text, it uses data. But also when people start using AI chatbots to generate photos or generate videos, that uses more data. And also when these chatbots have to start thinking for themselves, understanding complex things, that uses data. And it's just like the system is designed to fail. So there's a problem with data centers on Earth, and unless these data centers are regulated, that will kick the can down the road much further. But if they're not, then it's just going to ultimately lead to a lot of human problems, increasing climate change, global warming, disastrous things on Earth. And so, that's one of the reasons why it's important to start seriously thinking about having data centers in space. Some people say, like, oh, we should have data centers in space that is orbiting in outer space like a satellite. However, that's not really something that I would probably say like that probably would not be a good idea, especially considering like how are you going to get the power to power this data center in orbit. So the main thing would be to have data centers constructed on the surface of moon, and the power supply could be from the power supply that generates electricity is from space-based solar panels that are orbiting in outer space, and then they send down the electricity beams via a laser beam or microwave waves. But anyways, I'm going to read all of this. However, I'm going to just tell you generally how the data centers on the moon are going to be. Okay, so this is Moon Data Center, in which the orange part is the surface of the moon, the blue part is the data center. The data center can either be constructed above moon's surface, where this arrow is, or below moon's, or underground, which is below the orange line. And right here where it says data center is 1 built above the ground on the moon, or 2 built underground on the moon. And I said that 2 is the best option because you have to remember that the moon because the moon has no atmosphere, right where this arrow is. Since the moon has no atmosphere, the moon is constantly on a regular basis having very extreme regular temperature differences. So that is during moon's nighttime, temperatures can be negative 150 degrees Fahrenheit for 14 days, and then during daytime it could be positive 150 degrees Fahrenheit for 14 days. You know, it's like 14 Earth days for nighttime on the moon, 14 Earth days for sunlight on the moon. And also, since the moon has no atmosphere, you need to think about how heat is expelled from the data center. So on Earth, whenever there's like a data center that generates heat, or a stove that generates heat on Earth, since the Earth has an atmosphere and wind and things like that, heat is expelled through the process of convection. But however, on the moon, since the moon has no atmosphere and no wind and things like that, heat has to be expelled through the process of conduction, or heat is only transferred to other heat from the hot data center is only transferred to other solid objects that are connected to the hot data center. So like the data center will generate heat, and the data center will keep on generating heat, and heat can only be transferred to the cooling pipe, and then the cooling pipe becomes hot enough, and then it transfers heat into this black box, which is like a radiator or a radiator box, and then this black box is exposed to outer space, and then the radiator expels 100% of the heat into outer space, and that's how the heat is fully expelled. And the main thing, because it's on the moon, you have to think about expelling the heat through the process of conduction. But anyways, let me get into this now. Okay, so moon data center. Conduction process is for planets with no atmosphere like the moon, whereas convection process is for planets with an atmosphere like the Earth. You know, hopefully you know what no atmosphere moon and atmosphere Earth means. And because the Earth has an atmosphere, this also means that this is why Earth is able to have consistent, livable temperatures that humans can tolerate. But anyways, conduction, convection. Okay, here's Moon's ground level, the orange part. Here's the data center, the blue part, that is constructed underground on the Moon. And then there's cooling pipes connected to it. And then the cooling pipes are connected to the radiator or the radiator box. Well, you can read this part. Anyways, I'm right here now. The pipes / cooling pipes, which are right here. One end of the pipe is connected to the hot component. So the cooling pipe is right here, and then one end is connected to the hot component, the component that generates heat, the data center. And then two, the other end is connected to a radiator box, which is right here. This could be a radiator box or a radiator, but the key thing is that the radiator is exposed to outer space. Anyways, the pipe ends can be connected to the things of these things via either welding it or etc. In generality, this is how it goes. The component gets hot, so the data center generates heat, and it gets hot. And remember, the heat is only expelled through the process of conduction. So, if you know what conduction means, the heat can only be transferred if another object is touching the data center, the hot component. Convection is opposite. So component gets hot, data center gets hot, and then the hot / heat is transferred to the cooling pipe because of conduction, and then the cooling pipe, which will eventually get hot, transfers heat to the radiator or the radiator box, which apparently is exposed to outer space. And then the radiator, because it is exposed to outer space, the radiator finally expels 100% of the heat into outer space. And so outer space is like a giant vacuum that just sucks up the heat, essentially. That's how it works. And that is from the process of conduction. So that is one way how to do this. Option A, something that looks like this. Like this cooling pipe. There's one radiator or one radiator box, in which the radiator box could also be connected to like a radiator farm, like a farm of radiators on the surface. But you can do it another way, because I'm not sure what the rate of or how efficiently the heat is going to be transferred to the radiator farm. But it's something that looks like this. Okay. Now, the second picture is going to be the same thing. You have the process of conduction for planets with no atmosphere like the Moon versus the process of convection for planets with an atmosphere. In generality, it is a lot easier and it is much more efficient for heat to be expelled through the process of convection, but that is only on planets with an atmosphere like Earth. Heat is a lot more difficult to be expelled through the process of conduction for planets with no atmosphere like the moon. And so that's one of the main problems with data centers on the moon. Heat can only be expelled through the process of conduction, and it's just you need to find very effective ways for expelling the heat from data centers very efficiently through the process of conduction, because if heat is not expelled from the data center, then heat in the data center will only keep on getting hotter and getting hotter and getting hotter, and the heat will stay and remain within the data center because there's no atmosphere, there's no wind, there's no convection process. Heat will only keep on growing hotter and hotter and hotter inside the data center until the data center fails very quickly. And also, same thing goes with cold temperatures. If the cold temperatures are not expelled from the data center will keep on getting colder and colder and colder and colder until it freezes into like a block of ice, because you have only heat is transferred through the process of conduction. Only cold is transferred through the process of conduction. So anyways, basically what the bigger picture is that the data center is pretty much always generating heat. Whenever the data center is in operation, it is always generating heat. It is always getting hot. Now the trick is that there needs to be 100% efficiency or above 100% efficiency to transfer 100% of the heat from the data center to the cooling pipes to the radiators to be expelled into outer space. Like, as an example, let's say that the data center generates 150 degrees Fahrenheit of heat every 10 minutes. Okay, so what that means is that the heat from the data center, which is 150 degrees Fahrenheit, needs to be constantly transferred 100% of the time to the cooling pipes, to the radiators to expel the heat, because if not, then the data center is going to eventually grow hotter and grow hotter and grow hotter and grow hotter and grow hotter, and then it will eventually fail and break. So like as an example, data center generates 150 degrees Fahrenheit of heat. Okay, and if 150 degrees Fahrenheit of heat is transferred, like heat is transferred to these things, transferred very effectively /100% effectively, and expelled into outer space very effectively /100% effectively, then I guess you could say I'm not sure what the term is called, but it'll be very good. Like the data center will be working for like an extremely long time, or then you will have reached this term called, you will have reached equilibrium. which just means that you will have reached equilibrium. Hopefully you know what this sentence means. And this would be successful. Okay, when it's successful based on this aspect right here, the data center generates 150 degrees of heat, and 100% of the time, 150 degrees of heat is transferred and expelled, and then that keeps the data center functioning for forever, or forever how long it's in operation for. Perfect example. Okay, that's based on this scenario. Now, the unsuccessful example, is going to be this. Data center equals generates 150 degrees Fahrenheit of heat. However, so the data center generates 150 degrees Fahrenheit of heat. However, let's just say that the cooling pipes, which are a number, and the radiators or the radiator boxes, which is a number, if those things are not adequate enough, so like let's just say if 150 degrees Fahrenheit of heat is not transferred very effectively. So like let's just say in this example it was 100% effectively. Okay, 150 degrees goes in, 150 degrees goes out, 150 degrees goes in, 150 degrees goes out. That is 100% effectively. But in this example, it's unsuccessful. So like let's just say 95% effectively, which is less than 100%. 95% effectively. And expelled. I mean, even if it was transferred, you know, like it does not even have to go to the process of expulsion yet. But even if it was transferred 95% effectively, that still is a failure in the long run. But anyways, 95% effectively and expelled into outer space. Let's just say, well, this would be like 95% effectively because it would be the same thing. Then you have failed to reach equilibrium. You have failed to do so. And then because it's unsuccessful, because it's 95%, 150 degrees generates in here, and data center generates 150 degrees Fahrenheit of heat. And then these things transfers and expels 142.5 degrees Fahrenheit of heat. So 150, 142.5 degrees Fahrenheit of heat. Then what that is going to mean is that it'll take a longer period of time because the two numbers are very close together, 150 and 142.5. But over time, and it could take like 1 month, 2 months, 3 months, 5 months, etc. But over time, what that means is that the data center is slowly going to start retaining more heat, and it will just keep on getting hotter in the data center and hotter in the data center and hotter in the data center. And then eventually, when it gets too hot, it's going to fail and become destroyed, and that's going to be a lot of money wasted. So, it's very important for it to be successful and everything to be 100% effective. 150 degrees generated in the data center, 150 degrees out. Or another aspect that could be successful, but it will just slow the process, is the data center generates 150 degrees Fahrenheit of heat, and then the transfer of heat and the expulsion of heat through whatever different means, many different cooling pipes, solar farms, etc. What it means is that um, the data center generates 150 degrees Fahrenheit of heat, and then the cooling pipes and all this other stuff is capable of transferring slash expelling 200 degrees Fahrenheit of heat, and then that is still successful. The only thing that will negatively affect the data center is that the data center will just, since it was 150 degrees and 200 degrees, 150 degrees and 200 degrees, so it is the opposite of getting hot. The data center will just start getting colder, perhaps, but it's very easy to fix the cold that the data center is generating. And if the data center gets too cold, because remember, you do not have air currents to get rid of the cold. You do not have the process of convection. You only have the process of conduction, which I explained earlier. But if the data center gets too cold, then it would freeze. But anyways, that's how to think about it and generally visualize it. So before I read the ChatGPT thing, which is going to be very long, I want to just talk about these things. So I was searching up a data center on the moon, and apparently they say that, oh, this is actually theoretically possible. I mean, it is not realistically possible yet because it has not been realistically done. It is theoretically possible, and it would be theoretically possible to an 80% to a 60% to 80% extent, which just means that once it gets as it gets closer to 100%, it becomes more realistically possible. And remember, it is very, very, very important for data centers on other planets to happen, because data centers on Earth, it is just a disaster that will happen within the next 5 years. I mean, all of the problems that data centers on Earth brings. Climate change, global warming levels rising, ocean temperature levels rising, places in Mississippi experiencing colossal flooding that happened a couple of days ago. I mean, that happened last week, before June 25th, 2026. And you also have power companies deciding to not supplying electricity to average citizens, but power companies supplying electricity to data centers. It's just a recipe for disaster. I mean, data centers are important because everything uses data, Browsing web uses data, watching YouTube videos uses data. But it's just like it's designed to fail. And the more people that use data, it's designed to fail. It puts more strain on everything else. So it is important for data centers on other planets. And so this says whatever it wants to say. There's the challenges, data centers projecting their bandwidth or whatever back to Earth is difficult because Earth has an atmosphere and there's atmospheric interference. But it just means that data centers on the moon for to help Earth out. Anyways, let's see. Build it underground. That's the best way to supply very sufficient electricity or power to the data center, because if you have the data center orbiting space like a satellite does, like in this picture, how are you going to supply the data center with like 1 gigawatt of electricity? I mean, the good thing about if data centers were orbiting outer space, like this one, the good thing about it is that since it's already in outer space, heat is expelled instantaneously into outer space. That's the good thing. But the thing is, how are you going to supply electricity to it? Well, I mean, I guess you could. But it's just like a lot more difficult to maintain the data center that's orbiting outer space because it's in outer space. It's flying around. It's not on ground. But anyways, so originally they said orbital data centers, probably orbiting outer space. That can be done, but however, on the ground it's a lot better. But it would be underground because the data center would be underground, so below on the underground of the moon, you just have to install it underground, because on the moon there's still meteorite direct impacts on the moon's crust layer that can cause problems, and extreme regular temperature differences. Although the main thing is going to be meteorite impacts. And even if the data center was constructed above ground and there was a sufficient shield around the data center that protected the data center from meteorite impacts, like in this one, it says that on the International Space Station there's standard armor on it, like a Whipple shield, and that Whipple shield is designed to cause meteorite impacts, dust particles that are traveling at like insane mile per hour aspects, to disperse across the entire enclosed gap. Like it's like it's like this shape, I guess you could say. It disperses across it so that the energy impact is reduced. The energy impact is spread out and better absorbed by the inner main wall of the spacecraft. That could happen for data centers that are constructed above ground on the moon. But when you have repeated meteorite impacts on this shield, it's going to just keep on causing damage, and that damage is eventually going to have to be repaired. So that is basically if there's small meteorite impacts. Like apparently according to the location on the moon matters. The location for the surface level of the moon matters. And according to data, if you go to this place that's located near the moon's equator, you will only receive about 23,000 micrometeorite impacts per year in this spot, and it can withstand that. But the key word is that these things are micro. They are very small. Even though 23,000 is a very large number, it will weaken the shield over time. However, there was it did say, like, something did say something about that every couple of years, so like Earth years or something like that, every couple of Earth years, although I do not know how many years that is on the moon, but every couple of Earth years, it says that every couple of Earth years, and I do not know how many years that is on the moon, but every couple of Earth years, there's going to be a few larger meteorite impacts. So rather than it being like 3 feet in length, that is micro, but every couple of years it is like 8 feet to 10 feet, and if that strikes the shield, oh my gosh, that is going to cause significant damage to the shield because it is much larger. Larger is bad, smaller is better, but however, if you constructed it underground, if you constructed the data center underground, and you need to maintain it and collect data from it, it is better to have it underground. But anyways, okay. So now I'm going to get into the aspect of okay, never mind. Okay, in the next video I will read this ChatGPT response that is titled as Lunar Data Centers, Lunar/Moon Data Centers, is it possible?